Hey guys, for this lab you're going to be looking at how does the displacement that you allow an object, in this case a low friction cart, to travel affect the time it takes to travel whenever you launch it at a constant velocity or a set velocity there. So how you're going to do this, you're going to have a low friction track set up here with magnetic stoppers on each end. The idea there is the cart won't go rolling off the end. It'll also have rubber feet down the bottom that you can adjust to make sure it's level. So before you even get started, make sure that the cart doesn't roll on its own. The idea is gravity won't accelerate it here. It's all going to come from the little spring. So you're going to take your cart, you're going to compress the spring to the second notch, kind of lifting up there. We'll help you with that in class. Then you will put the cart up against one of the magnetic stoppers. Now the magnetic stopper isn't going to launch it, it's going to be the spring in this case. Take note where the back of the cart is, because that is your starting measurement. You're going to let the cart roll first 0.2 meters or 20 centimeters, 0.20 meters or 20 centimeters. So my cart right now is at the 20 centimeter mark approximately. And whenever I launch it, I would start my stopwatch and I'd want to stop it whenever it hit the 40 centimeter mark. That's a displacement of 20 centimeters. So I would simply press the button at the very top of the cart, start and stop the stopwatch, start and stop the stopwatch whenever it goes from 20 to 40 in my case. Now your case might be slightly different depending on where your magnetic stoppers are. So if your magnetic stoppers are a little in front, a little behind, that could change where you start or stop. Your stopwatch, you would just want to only let it go 20 centimeters. And then you're going to repeat that process. You do 5 repetitions of 20 centimeters, and so you do it again. Start and stop 20 centimeters, and then you would do it for 40 centimeters, do that 5 times, so forth and so on for 20, 40, 60, 80, and then for a full meter. Record all of that down in your raw data table. You'll end up getting a nice graph. We're actually going to flip-flop your displacement and your time. Normally, we would plot the independent variable on the x-axis, which happens to be displacement in this case, and your dependent variable on the y-axis, time. This lab, we're going to flip-flop it. We're going to put displacement on the y, time on the x, just for good motion graph reasons.